Hey, so we are doing homework number 5, problem number 2. Given f of x comma y equals to 1 over a x squared y, where x is greater than always is great. X is always greater than or equal to 1, and y is between 1 over x and x non-inclusive. Draw the non-zero definition region of f of x comma y. And over here is what we have. Given f of x comma y, I rephrase the question. And basically, this line over here is y equals to x, and this curve over here is 1 over x. We want to find everything in between. And remember, it's non-inclusive. It's not less than or equal to. Okay, so that is the curve. So let's move on to the second part. Find a so that f of x comma y is a valid joint density function. I call it a VJDF. I rephrase the question on top of it there. Find a so that f of x comma y is a VJDF. For a function to be a VJDF, you need to set the integral equal to 1. For our case, we need to set the double integral equal to 1 since we have two variables. Here's what we do. The bounds are a little difficult to find. For the x bounds, we set it from 1 over x to x because we need to find where where it meets, right? So the bottom curve, right, is 1 over x, and the top curve is x. So that's why we set it from 1 over x to x. For the y integral, the bounds for that, we set it from 1 to infinity because that right there is 1. That's where it intersects, and everything really is above that is infinity. So that's why we have that. And here we have some math going on. It's difficult. It was difficult doing the U substitution. Over here in the bottom right hand corner, we have a little bit of uv minus vdu, integral vdu. Eventually we arrive at an answer of a equals to 2. Okay, so for the third part, we want to find and draw the marginal density functions of f of x and f of y. To find the marginal density functions, you basically take the integral. If we want to find, for example, if we find f of x, we take the integral in respect to y, and which is what we have here. F of x equals to the integral from negative infinity to infinity f of x comma y dy equals to, again, our bounds are 1 over x to x because we're going to go back to our original curve right here. The bottom line in the shaded part is 1 over x, and the top part is x. So that's why we have bounds like that. So we basically just integrate it. We end up with ln natural log of x over x squared. Same thing for f of y. We take it in respect to x. So f of y equals to negative infinity to infinity. F of x comma y dx equals to 1 over y to infinity. 1 over 2x squared y dx. Let me comment a little bit about the bounds. Okay, so as you can see here, a little side note, this is for y between 0 and 1. And the reason is because going back to the graph, it's not exactly the same. The marginal density function values is not the same after it's greater than 1, like over here. Okay, and so that's why we set the bounds from 1 over y. And it's 1 over y because what's your bottom curve, right? It's 1 over x, right? But you need it in terms of y. And so y equals 1 over x, therefore x equals 1 over y, and that's why the bottom bound is 1 over y. Do a little integration, we end up with 1 half. And then for everything above y, we have y to infinity, 1 over 2x squared y dx. Pull out 1 over 2y, integrate 1 over x squared, we get negative 1 over x. Put in infinity, negative 1 over infinity is always 0, minus 1 over y, which is plus y, and 1 over 2y times 1 over y is 1 over 2y squared. And that's for all the values for y greater than 1. And over here we have the marginal density function f of y is equal to 1 half for y between 0 and 1 non-inclusive, and equal to 1 over 2y squared for y greater than 1 non-inclusive. Okay, we're going to move on to drawing the marginal density functions now. Here I have f of x, and basically I just plug in values to see where it was at, and it started at 1, and basically it just gets really close to kissing 0, but there's an asymptote right here. Okay, same thing for f of y. Again, remember between 0 and 1, it's 1 half, so that's gonna be a flat line right there. Sorry, right there. Okay, and then everything, this curve right here is the 1 over 2y squared curve, okay? And I found out basically by plugging in values to see where the graph would lead, okay? Finally, we need to verify that f of x and f of y are valid density functions. And the way we do that, like in problem number 1, is we set the integral equal to 1. So right here, we're showing that the integral from negative infinity to infinity ln natural log of x over x squared dx is equal to 1. And this is from our previous work, and as I will show you, where is it? Right here. From our previous work, we have already shown that it is equal to 1 when a equals to 2. So that's how we found a in the first place. So that's how we know it's equal to 1. But for f of y, we actually have to do the work. And we need to do it from 0 to 1 for 1/2 dy and from 1 to infinity for 1 over 2y squared dy, which is very simple arithmetic, and we end up with 1. So therefore, they're both valid joint density functions, f of x and f of y. I mean, no, not joint density functions, marginal density functions, valid marginal density functions. Thank you, and that was homework number 5, problem number 2.